ESA launched a call for opportunities to build a high-resolution, extremely precise spectrograph for the ESA 3.6-meter telescope at La Silla, Chile. Michel Mayor from the Geneva Observatory led a consortium to build HARPS, which was installed in 2003, and was soon able to measure the back and forward motions of stars by detecting small changes in a star's radial velocity, as small as 3.5 kilometers per hour, or a steady walking pace. Such a precision is crucial for the discovery of exoplanets. The radial velocity method, which detects small changes in the radial velocity of a star as it wobbles slightly under the gentle gravitational pull from an unseen exoplanet, has been the most prolific method in the search for exoplanets.
In return for building the instrument, the HARPS consortium was awarded 100 observing nights per year over a 5-year period. Now this time was used to carry out one of the most ambitious systematic searches for exoplanets that target planets worldwide by measuring the radial velocities of hundreds of stars that lie in our planetary systems.
The program soon proved very successful. Using HARPS, Mayor's team discovered, among others, the first super-Earth around Mu Ara, the trio of Neptune around HD 69830, Gliese 581d, the first extrasolar planet in the habitable zone of a small star, and the lightest exoplanet ever detected around a normal star, Gliese 581e. More recently, they found a potentially lava-covered world, with density similar to that of the Earth.
These observations have given astronomers great insight into the diversity of planetary systems, and have helped us to understand how they might form.
The HARPS consortium was very careful in their selection of targets, with several sub-programs aimed at looking for planets around solar-like stars, low-mass dwarf stars, or stars with a lower metal content than the Sun. Although it was thought that giant planets couldn't form around low-mass stars, the HARPS team has found several of them. The number of exoplanets known around low-mass stars, so-called M-dwarfs, has also dramatically increased, including new super-Earth candidates.
Although the first phase of the observing program is now officially concluded, 2 new programs have been started, and the team still expects to make many new discoveries from the first 5 years of data. There is no doubt that HARPS will continue to lead the field of exoplanet discovery, and especially pushing towards the detection of Earth-type planets. This is Dr. J, signing off for the ESOcast. Join me again next time for another Cosmic Adventure.
To visit all major observatories in the world, covering every continent in the space of just 24 hours. ESA made a trip around the world in 80 telescopes during a live 24-hour webcast. Let's go behind the scenes to find out how it was done. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the universe's ultimate frontier with our host, Dr. J, aka Dr. Joe Liskin.
Hello and welcome to the ESOcast. In this episode, we're going to follow an incredible 24-hour live webcast that was produced at ESO headquarters on April 3rd and 4th, 2009. This webcast was called Around the World in 80 Telescopes, and it attracted well over 100,000 online viewers. The webcast was part of 100 Hours of Astronomy, a cornerstone project of the International Year of Astronomy 2009. Let's now go backstage to see how this record-breaking event unfolded.
The ESO headquarters in Garching, near Munich in Germany, is hosting the live 24-hour webcast that will follow night and day around the globe and visit some 80 different observatories on the way. This is a major technical and logistical challenge. Preparations have been underway for months, and with 1 day left to go, the pressure is on to get things ready.
After a long final night of testing, the morning of the webcast is here. And the project leader, Douglas Pierce Price, is pleased with the preparations.
This is the culmination of a lot of extremely hard work by people here at ESO, and of course of all of the observatories around the planet that we'll be visiting during this amazing 24-hour live webcast. Things are very, very busy behind the scenes, but we're getting things in place, we're almost ready to go, and we're looking forward to it.
Before we delve into the rest of the day, what does it actually take to run a live webcast like this? Well, apart from having many wonderful observatories around the world to visit, you need a project leader that remains calm under pressure, a first-class production team, hilarious technical experts that put our guests at the observatories at ease, top-notch multi-key operators, a web team, a professional looking set, and 6 attention style presenters. Oh, and of course, an on-set product.
Just a few minutes before the start of the webcast, and some final adjustments are made. The Gemini North Observatory in Hawaii will be the first stop in a long journey around the world. Everybody is in position as the webcast begins.
Hello, you're joining us for Around the World in 80 Telescopes, a live 24-hour webcast.
The webcast is a unique chance to experience a snapshot of life at many different observatories around the globe, and to find out what astronomers are actually doing at the telescopes and what they hope to discover. However, like many live events, the webcast is not without initial setbacks.
Just over an hour into the broadcast, the streaming provider has a problem, leaving a blank screen with thousands of viewers. No one's not lost as the webcast continues, with segments being recorded and uploaded online. Lee Quillen of the Cosmic Diary, another cornerstone project of the International Year of Astronomy 2009, is writing a behind-the-scenes live blog. His posts keep the audience informed, so nobody is left completely in the dark. After a tense and stressful half hour, we're back on air. Once again, the telescope tour is on track. With 24 hours of constant airtime, the webcast team work in shifts. People swap in and out of their positions, ensuring a continuous presence. The webcast is running smoothly, so Douglas takes an early evening break to eat a quick meal. The menu for the event was carefully chosen in order to keep the team happy during the long hours. Although the team could have had a selection of the Bavarian dishes, they opted for a range of international foods in honor of the event. Over halfway through the webcast, the day has gone well. Viewers watching from all over the world have emailed in feedback and questions to be read out by our hosts on air.
And this is a question from Julie, who writes in from the UK.
The night shift team keeps things running in the early hours, while Douglas finally gets just 1 hour of well-deserved rest.
The dawn of the next day marks the final stages of the webcast. The tired and slightly delirious team receives a much-needed boost when the video from the Vatican Observatory is broadcast. Even after 20 hours, the team spirit is still high.
Finally, the webcast is over.
And so this brings us, after 24 hours of webcasting, to the end of Around the World in 80 Telescopes. We also
With more than 24 hours of continuous interviews completed, the time has come to celebrate the successful event with a glass of champagne.
I hope you enjoyed the look behind the scenes of Around the World in 80 Telescopes. It was an incredible event, but I'm sure there'll be other spectacular outreach activities from ESO in the future. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
Current exoplanet research is the detection of a rocky Earth-like planet in the habitable zone, a region around the host star with the right conditions for water to be liquid on their surface. The latest result from the European Southern Observatory comes closer than ever to attaining these goals. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the universe's ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to another episode of the ESOcast. This time we have some very exciting news for you. It's another major ESO discovery. We'd like to tell you about the discovery of the smallest, or rather lightest, and possibly most Earth-like planet so far discovered outside of our own solar system. We'd also like to report on yet another planet within the same system that has now been shown to lie within the habitable zone of its parent star, meaning that it could host liquid water and possibly even life.
Gliese 581 is a seemingly inconspicuous red dwarf star located 20.5 light-years away in the constellation Libra, or the Scales. It is among the 100 closest stars to us and weighs only one-third the mass of the Sun. Such red dwarfs are intrinsically at least 50 times fainter than the Sun and are the most common stars in our galaxy. For astronomers studying exoplanets, red dwarfs are ideal targets for the search for low-mass planets where water could be liquid. Because such dwarfs emit less light, the habitable zone is much closer to them than it is around the Sun, which makes it easier to detect the planets.
Professor Michel Mayor from the Geneva Observatory and his team of European astronomers have carefully observed Gliese 581 over the past 4 years using the world's leading planet-hunting instrument, the HARPS spectrograph, on the ESO 3.6-meter telescope at the La Silla Observatory in Chile. Now what they found was that Gliese 581 is orbited by a planet that has only 1.9 times the mass of the Earth. This planet is known as Gliese 581e and is the lightest and most Earth-like planet so far discovered outside of our own solar system. Now within the very same system, the team also refined the orbit of a previously known planet called Gliese 581d. What they found was that this planet is definitely within the habitable zone of its parent star. Now what that means is that the planet is just at the right distance from the star for any water that might be present at its surface to be liquid. If it were any closer, the radiation from the star would be too strong and the water would evaporate. If it were any further away, it would be too cold and the water would freeze.
From previous observations, also done with the HARPS spectrograph at ESO's La Silla Observatory and announced 2 years ago, this star was known to also harbor a system of 3 super-Earth planets. With Gliese 581e, the planetary system has 4 known planets, with masses of about 1.9 planet E, 16 planet B, 5 planet C, and 7 Earth masses planet D.
The planet with the largest orbit in the system is Gliese 581d, and it takes about 66.8 days for one round trip around its parent star. Now because it orbits within the habitable zone of its star, this planet could be covered in liquid oceans, making it the first serious water world candidate.
Thanks to Mayor and his team, we now know that the Gliese 581 system contains at least 4 exoplanets. These planets were discovered through the tiny wobble they cause to their host star as they move around, only about 7 kilometers per hour, which equates to brisk walking speed. The discovery of Gliese 581e and the refinement of Gliese 581d's orbit were possible only due to HARP's unique precision and stability.
Using the HARPS spectrograph, Michel Mayor and his team of European exoplanet hunters are leading the way towards answering some of our most fundamental questions about life outside of our own solar system. They are confident that in the not-too-distant future, a truly Earth-like planet will be discovered. So stay tuned. This is Dr. J, signing off for the ESOcast. Join us again next time for another cosmic adventure.
Of the International Year of Astronomy 2009, ESO has launched a new project aimed at connecting the sky, as seen by the unaided eye, with that seen by hobby and professional astronomers. The project, called Giga Galaxy Zoom, reveals 3 amazing ultra-high-resolution images of the night sky that online stargazers can zoom in on and explore in an incredible level of detail. The reward is the most breathtaking dive ever made into our galaxy, linking the sky seen by all with the cosmos studied by astronomers. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Amazing Giga Galaxy Zoom project, which reveals the whole night sky as it appears with the unaided eye from one of the darkest feathers on Earth. The project allows users to zoom in on a rich region of the Milky Way with a magnification offered by a hobby telescope, and then to go one step further, using the power of a professional telescope to explore details of the iconic nebula. Most of the photographs comprising the 3 Giga Galaxy Zoom images were taken from La Silla and Paranal, 2 of ESO's observing sites in Chile. The wonderful quality of the images is a testament to the splendor of the night sky at these ESO sites, which are the most productive astronomical observatories in the world. The first image, taken by the renowned French writer and astrophotographer Serge Mounier, aims to present the sky as people have experienced it the world over, though in the far greater detail offered by top-notch stargazing conditions and incorporating the view from both hemispheres. Mounier spent several weeks capturing the sky with a digital camera, mostly from ESO observatories at La Silla and Paranal in Chile. To cover the full arc of the Milky Way, Mounier also made a few long trips to La Palma, one of the Canary Islands, to photograph before this skies. The final image, the result of 120 hours of observation, provides a magnificent 800 million pixel surrounds our tiny blue planet. The plane of our Milky Way galaxy, which we see edge on from our perspective on Earth, cuts a luminous swathe across the image, almost as if we were looking at the Milky Way from the outside. The second image was captured by another renowned astrophotographer named Stefan Issa. Stefan is also the chief physician at the ESO Paranal Observatory, where he is responsible for making sure that the Very Large Telescope has the best possible optical quality. This second image directly benefits from the dark and cloudless sky at Paranal, one of the best observing sites on the planet, and from Stefan's professional expertise as an optical engineer specializing in telescopes. To snap the photographic mosaic of the central parts of our galactic home, Stefan relied on a 10cm aperture Hobby telescope coupled with a CCD camera. The final result produced by Stefan, together with ESO's image expert, is a color image of the Milky Way containing more than 340 million pixels. The image combines about 1,200 photos for a total exposure time of at least 250 hours. The resulting image beautifully exhibits the sky, spanning several constellations from Sagittarius to Scorpius, an area that includes the galactic center, the famous Lagoon and Trinket nebulae on the left, and the colorful Antares and Rho Ophiuchus region on the right. The third image of the Giga Galaxy Zoom project illustrates the power of professional astronomy. It covers a 1-degree field of view, or about 2 times the width of the full moon, using the wide-field imager attached to the MPG ESO 2.2-meter telescope at the ESO Lassia Observatory. This camera has already created several of the most iconic pictures produced by ESO. The professional image is a zoom into the attractive and intriguing Lagoon Nebula. Scattered dark patches within this 100 light-year-wide nebula are huge clouds of gas and dust collapsing under their own weight. Soon they will give birth to clusters of young, glowing stars. Together, these 3 stunning images allow for unique exploration of a magnificently detailed cosmic environment from the scale seen by the unaided eye into the astronomer's realm. Enjoy this dive into the starry depths of our Milky Way, from the eye to the telescope. has just released a stunning new image of a field of stars towards the constellation of Carina. This striking view is ablaze with a flurry of stars of all colors and brightness, some of which glow against a backdrop of gas and dust clouds. A complex nebula created by previous violent ejections surrounds an unusual star in the middle of this field. Astronomers have discovered that this star has a companion. Interactions in this double-star system, surrounded by a dusty disk, may be the engine fueling the star's remarkable nebula. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the far reaches of the universe with our host, Dr. J, aka Dr. Joe Liston. Hello, and welcome to this episode of the ESOcast. My name is Katie Hussain. I'm standing in this time for Dr. J, who is on vacation. Today we will explore a new beautiful ESO image that shows a rich field of stars centered on a star called HD 87643. A study using a new set of observations has provided astronomers with the best ever views of this exotic type of star. The image, taken in the direction of the constellation of Carina, shows a dense starscape towards the Carina arm of the Milky Way galaxy. As we come closer, we see the star HD 87643, a so-called BE star, at a distance of 4,900 light-years. The image beautifully shows the extended nebula of gas and dust that reflects the light from the star. The central star's wound appears to shape the nebula, leaving bright, ragged tendrils of gas and dust. A careful investigation of these features seems to indicate that there are regular ejections of matter from the star every 15 to 50 years. The comprehensive new study uses 3 different instruments in ESO's arsenal of telescopes. First, for the big overview, astronomers turn to the wide-field imager on the MPG ESO 2.2-meter telescope at the 2,400-meter high Lassia Observatory in Chile. Secondly, the team used ESO's Very Large Telescope, or the VLT, at Paranal. Here, the NACO Adaptive Optics instrument allowed astronomers to obtain an image of the star free from the blurring effects of the atmosphere. To probe the object even further, the team then obtained an image with the Very Large Telescope Interferometer, or the VLTI for short. The sheer range of the set of observations from the panoramic wide-field imager shot to the fine details of the VLTI observations corresponds to a zoom-in factor of 60,000 between the two extremes. With this data, the astronomers found out that HD 87643 has a companion star located at about 50 times the Earth's sun distance and is embedded in a compact dust shell. The two stars probably orbit each other in a period between 20 and 50 years. The presence of this companion could provide an explanation for the regular ejection of matter from HD 87643 that forms this amazing nebula. As the companion star moves in a highly elliptical or oval-shaped orbit, it regularly comes very close to HD 87643 and triggers an ejection of stellar material. This celestial tango may be what generates the gorgeous nebula. Once again, science has helped us explore and explain the beauty of the universe. This is Casey Hussain signing off for the ESOcast. Join us again next time for another cosmic adventure. Worldwide, most of the glory goes to the astronomers who provide us with new vistas of the heavens. But this is only possible thanks to the many experienced technicians and engineers who accomplish amazing work behind the scenes. They work against the clock to ensure that the telescopes function optimally to deliver outstanding results. So what does an engineer at ESO's Very Large Telescope actually do? This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the universe's ultimate frontier with our host, Dr. J, aka Dr. Joe Lisbon.
Welcome to another episode of the ESOcast. The completion of ESO's Very Large Telescope in the year 2000 was not only an amazing scientific achievement, but it was also a technological triumph. The VLT at Mount Paranal is the world's most advanced ground-based optical telescope, and it attracts astronomers from all over the world. But this complex high-tech facility can only function because of the dedication of the Paranal Engineering Department. Highly skilled VLT engineers like Roberto Castillo work with unsurpassed precision against the clock to make sure that every single piece of high-tech machinery works perfectly. Let us now dive into an exciting day in the life of a VLT engineer.
Roberto Castillo works in the VLT instrument team. He is responsible for parts of the VLT instruments, and as unit telescope manager, he is in charge of handing over one of the 4 giant 8.2-meter telescopes to the astronomers at the beginning of each night. First stop, the office. Roberto checks on the workload and identifies the most critical issues that must be dealt with. He interacts closely with colleagues and scientists who wish to have some of the instruments checked during that afternoon. The countdown has begun. All problems must be solved before sunset.
Although this might seem a job like any other, the extreme complexity of the VLT presents the Paranal engineer with a variety of challenging tasks, each of which must be performed quickly and with supreme precision. What's going on? Roberto's on the radio. Paranal, yeah, no. I go to the telescope to check the instrument.
The problem must be solved. Roberto leaves his office and crosses the platform. Problems usually don't come alone. On his way to the telescope, Roberto interacts with his colleagues and checks some components. Each of the 4 giant VLT telescopes is equipped with several extremely powerful, yet very delicate instruments. An engineer at Paranal must have a specialized knowledge of all the components in case of technical malfunctions to ensure that the VLT is ready for observations every day, and downtime due to technical problems is kept to a minimum.
As sunset slowly approaches, Roberto's already engaged with his next important activity, the daily coordination meeting in the control building. This is where all the scientists and engineers get together to report on all the important issues encountered during the day and to prepare for the night. For Roberto, this moment is especially crucial. As a unit telescope manager, he is responsible for handing over the telescope in perfect shape to the astronomers for the night. Let's follow him as time ticks away.
Each minute becomes even more precious as sunset draws near. Roberto rushes to his telescope to initiate the standard startup sequence. The telescope can be handed over to operations only when every single task in his checklist is complete. This moment is the culmination of all of Roberto's hard work, and with smooth and precise commands, the steel and glass giant gently awakes. The sun has now completely set. This is the moment of truth. Roberto is now able to say the magic words to the telescope operator.
Attention, duty 2 operator. Go ahead. The telescope is ready for you. So, this finally marks the end of Roberto's challenging workday. The astronomers now take control of the VLT, and the telescope will soon come to life. As night falls over Paranal, and as the celestial display takes the front seat, Roberto is heading back to the Residencia to enjoy a relaxing dinner with his colleagues. Although his day is officially over, Roberto must remain reachable and prepare to react swiftly in case a problem should arise at the VLT during the night. Behind every great astronomer stands a great engineer. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
얘가 또 격한 순간은
What it must be like to be an astronomer. Let's take you behind the scenes and see what 24 hours in the life of an ESO staff astronomer is like. The countdown for an exciting night with an observation run at the world's most advanced optical telescope, the ESO VLT, has begun. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the universe's ultimate frontier with our host, Dr. J, aka Dr. Joe Lisbon.
네가 이왕
Welcome to the ESOcast. In today's episode, we're going to follow a day in the life of Dieter Nürnberger. Dieter is a staff astronomer at ESO. His job is to support those scientists that have managed to get observing time on ESO's Very Large Telescope, the Paranal Observatory in Chile. Now, ESO receives about 1,000 applications for observing time every 6 months, and only about 1 in 5 of those are actually selected. Dieter spends most of his working days helping the successful few to make groundbreaking discoveries.
Dieter Nürnberger is on his way to meet the visiting scientist Chris Toomey and his PhD student Stephen Piper to team up for the night to come. The three have been observing together for several nights. Today is their final evening and they're keen to get started. Over dinner, they discuss plans for the night ahead. Well before sunset, they leave the Residencia and drive up the desert road to the building housing the VLT control room. At the control building, they prepare the observations and check the setup of the telescope. Observing time on these great telescopes is precious and delays must be avoided at all costs. Like a pilot checking his plane before departure, Dieter goes through a detailed check of his instrument, while the telescope operator does the same for the giant telescope. Everything is good to go, so the team goes to the telescope platform to inspect the weather. The astronomers have traveled far for a glorious view of the universe, and here a glorious view of the sunset is just the same. As usual, conditions are perfect.
of the universe. Let's join them and see how the first observations of the night are going.
Cocooned in the high-tech environment of the control room, the observing program is underway. Although the observation is running smoothly, it still requires the full attention of our team. The telescope and weather